So let's quickly review some unit conversions we did last week. Let's say that I have 3.47 grams of sodium hydroxide, and I want to know how many moles of sodium hydroxide that this corresponds to. Again, I'm going to start with what I know. I know I have 3.47 grams of NaOH. Now, if you look at your periodic table, element 11 is sodium. Sodium has a mass of 22.99. Oxygen, which is element 8, has a mass of 15.9994. And hydrogen, element 1, has a mass of 1.0079. And I'll just add all of these together. Now, as a chemist, I usually round things off so I can do this in my head. So I would say sodium is 23, oxygen is 16, hydrogen is 1. So this is going to be 40 grams of NaOH is 1 mole of NaOH. And then I'm just going to simplify this on the calculator. So when we simplify the expression, we get 0.086 moles of NaOH. Make sure you include the unit with the number. So let's do another conversion where we're going from grams to mole. Let's say that I want to do the ammonium dichromate volcano reaction, and that to do this I need 3.76 grams of ammonium dichromate. I really think the first thing, we know that we're going to start with what we know. I know that 1 mole of ammonium dichromate is equal to the gram formula weight of ammonium dichromate. So I need to either use my periodic table or my app to determine what the gram formula weight of ammonium dichromate is. Notice I have 2 nitrogens, and each nitrogen is 14.0067. So I'm going to multiply that by 2. I have 8 hydrogens. Each hydrogen is 1.0079. I have 2 chromiums. Each chromium is 52.01. I have 7 oxygens. Each oxygen is 15.9994. So the molar mass is 252.06 grams of ammonium dichromate. And grams of ammonium dichromate will cancel. And I'm left with moles of ammonium dichromate. So when we simplify this answer, we get 0.014 moles of ammonium dichromate. So now let's have you guys try one. I have 2.33 grams of fructose, which has a formula of C6H12O6. And I want to know how many moles of fructose I have. So again, we're going to start with what we know.
You know what that means?
So we have 2.33 grams of C6H12O6. There are 180 grams of C6H12O6 in 1 mole of C6H12O6. By the way, this is not only the formula for fructose, but also glucose, galactose, mannose, cellobiose, et cetera, et cetera, et cetera. There are 16 structural isomers of this particular kind of carbohydrate. So when I simplify, it's just going to be 2.33 divided by 180 moles of C6H12O6. So 0.0129 moles. You could also say 1.29 times 10 to the minus 2 moles. Either of those answers would get full credit.